Okay, so today we're looking at areas enclosed by the x-axis. So, our learning intention is to gain the knowledge in calculating the area under a curve and the x-axis. So we'll be successful if we can calculate areas above the x-axis or below, and calculate areas involving odd and even functions. Okay. When we want to calculate the area above the x-axis, so from the point of A to B, what we want to do is we want to so the area under the curve, the x-axis, and between A and B, what we want to do is we want to find the integral from B to A of the function dx. Alternatively, if we want to calculate the area under the curve, so in this situation, it'll be above the curve, the x-axis and A and B, then that's going to be the absolute of the integral from B to A of the integral of the function dx. One of the things to do is it's really important to sketch the graph of the function and the bounded area to get an idea of what we're doing. Okay, sometimes we need to, we have a bit of the function above and a bit of the function below. So we have to do a combination of areas. So for example, in this one, I'm going to have the integral from a to 0, maybe I'll write that, from a to 0, or negative a to 0, of the function, and then I'm going to add it with the absolute from 0 to b of the function to find the total area. Now with odd functions, if they're equally spaced, what happens is if I calculate the area of this part from negative a to 0, and then from 0 to a, this area will cancel out this area, giving me a total area of 0. Okay, so be careful when doing that. So if they want an actual area question, you've got to be conscious that if you're getting an answer of 0 area, that it may be an odd function. Now with even functions, so if I have from negative a to a, this area from negative a to 0 is the same as 0 to a. So it's basically double the area from 0 to a. Let's do some examples. All right. We want to find the area bounded by the curve of y equals negative x squared plus 9x minus 20. So what I'm going to do first, I'm going to factorize this. So x plus 5, x minus, so that should be a 9, sorry. X minus 5x minus 4. So really this y-axis should be over here, and this would be negative 5, negative 4. Okay, so we know that's a parabola concave down, and the first thing, so we're going to figure out what we want to do is we want to integrate, sorry, that should be, positive 4, positive 5. Sorry, positive 4, positive 5. So we actually, the y-axis is over here. We want to integrate from 5 to 4 of this function. Okay. So what we're going to do, that become x cubed on 3 plus 9x squared on 2 minus 20x from 5 to 4. Okay. So by plugging in 5, So if I go negative 5 cubed over 3 plus 9 lots of 5 squared over 2 minus 20 over 20 times 5. So we get negative 175 over 6 minus, now if I plug in 4 into this, I'll get negative 88 over 3. Okay. So my solution is 1 over 6. Now remember it's an area, so it's units squared. Okay, we'll do another example. I'm going to find the area bounded by the curve y equals x minus 9, so x squared minus 9. So if we factorize that, that would be x minus 3x plus 3, the difference of two squares. So we get negative 3 and 3, quick sketch. So we're going to calculate the area between negative 3 and 3, the x-axis, and above the curve. So what we want to do is we want to integrate from 3 to negative 3 of x squared minus 9 dx. Now, because it's under the curve, I'm definitely going to take the absolute value. Okay. Now, I'm going to imagine not taking the absolute just yet, and to show you what we're going to get. So we're going to integrate this. So we get x cubed over 3 minus 9 over, so 9x from 3 to negative 3. Okay. Now, if I plug this in, I'm just going to show you what I get. So I'm going to get negative 3 cubed over 3 minus 9 lots of negative 3. Okay, so that's 18. Sorry. What's that? Right. And if I plugged in positive 3, I would also get 18. Yep. Which would give me a solution of 0. Okay, because this function is also an even function. So what I really want to be doing is I want to actually take two lots. Sorry, I'll do it again over here. So what we really want to do is we want to have two lots of the integral from 0 to 3 of x squared minus 9 dx. So it's still going to be x cubed on 3 minus 9x from 3 to 0. So that's going to be 27 divided by 3 is, so we got negative 18 and minus 0. So we get two lots of negative 18 in this case, okay, which is negative 36. But remember that we have got underneath the curve, so we really want to take the absolute of all this to give us an area of 36 units squared units. Okay, so it is important to kind of draw your graph to keep that reminder of what area we're trying to calculate. Okay. So we want to find the area enclosed between the curve y equals x cubed, the x-axis, and the lines x equals -3 and x to 2. Okay, so looking at this part, we really want to take the integral from -3 is my final point to 0 of x cubed, and I want to take the absolute of that because that's under the curve. Don't forget the dx. And then I'm going to add that to the integral from 2 to 0 of x cubed dx. Okay, so this is still going to be x to the power of 4 over 4. This is the absolute from 0 to -3 plus x4 over 4 from 2 to 0. So doing the first part, I've got 0, so it's absolute of 0 minus, -3 to the power of 4 is 81 over 4. Okay, and we're going to add that to 2 to the power of 4, 16 divided by 4 is 4 minus 0. So really we've got 81 over 4 plus 4. Gives us 97 over 4 squared units. Okay, taking it bit by bit. Alright, let's do a trig function. We want to find the area enclosed by y equals sine x and the x-axis in the domain from 0 to 2 pi. Now if we think about this area will cancel out this area. So what I really want to do is I actually only want to double the area of the integral from 0 to pi of sine x dx. Okay, so when we want to integrate sine x, what we're going to get is we're going to get negative cos x. Okay, and that's going to be from 0 to pi. Yeah. Okay. So negative cos on pi minus negative cos on 0. So cos of 180 should be -1, so that's, maybe I'll do it like that. And cos of 0 is 1, so that's -1. So we get 1 plus 1, which is 2. 2 times 2 is 4 squared units. And that's the solution. Here's our last example. We want to find the area enclosed by 3 cos of x. Okay, and the x-axis in the domain from -pi and pi. So here I've drawn it. I notice that these two will cancel out, and these two will cancel out. So really, because it's symmetrical, I really want to basically get double the integral from -pi to pi. Oh, so these are pi on 2. okay, of 3 cos x dx. Okay, because I basically want to double this to get that, and double this to get that, and add those two together. So taking out the 3 with the 2, so I get 6 integral of negative pi on 2 to pi on 2 of cos x dx. So we know that that's negative sine of x. And we're going from pi on 2 to negative pi on 2. Okay. So negative sine pi on 2 minus negative sine negative pi on 2. Okay. So we get negative 1 so minus negative 1. So that becomes a positive, that becomes we get negative if I have positive cos, so these are positive signs. So if I differentiate sine, I should get positive cos. Sorry. That's positive 1 minus negative 1. Okay, so that becomes positive 2, which becomes 12 units squared units. Okay, thank you very much.